Hello all, Monday, May 11th, day 3 of 4 of logarithms. We are nearing the end. Okay, so we are going to do some solving over the next couple of days. There's some different things that you need to look at. So this first one is you're actually solving exponential equations where the variable is part of the exponent. So this is called the property of equality. So basically, if I can get equal bases, then I can solve. So you're going to have to think about your exponents. Okay, so for this one, my base is already the same. So the property of equality tells me that if the bases are the same, I can solve for the exponent. All I have to do is set up an equation and solve. So if I subtract x from both sides, I get x equals 3. Oops, that's an x. Okay, so you can see if you put a 3 here, you get 2 to the 6th. If you put a 3 here, 2 times 3 is 6. So you get 2 to the 6th equals 2 to the 6th. That was a pretty easy one. Okay, so on this one, I have a base of 3 and a base of 27. So I need to change this base 27 to base 3. Then I can apply my property of equality. So this side's not going to change. My 27 is going to go 3, oops, sorry about that, 3 to the 3rd. Make sure you put that in parentheses, and your exponent is still 2x plus 1. So now I have my base 3, but I still need to apply my property of exponents. This would be called a power of power, where you're going to distribute that 3 to the exponent 2x plus 1. So now to solve, I have x plus 3 equals 6x plus 3. If I subtract 3 from both sides, I get x equals 6x. Common sense tells me that x has to be 0, but if I subtract x from both sides, I get 0 equals 5x. So x is 0. So to check, if I have a 0 here, 0 plus 3 is 3, so over here I have 3 to the 3rd. If I put a 0 here, I have 2 times 0 plus 1, which is 27 to the 1st. 3 to the 3rd is equal to 27, so my answer is correct. Remember, on exponential equations, the domain of x is all real numbers, so there's no restrictions to worry about. Okay, so for this one, I have a 3 and I have a 1/9. So I'm going to change my 1/9 to base 3, which is 3 to the negative 2. So now I have 3 to the negative 2. Remember, I have to distribute these. My bases are the same. They're both 3. So I have x equals negative 2x minus 6. If I add 2x to both sides, I get 3x equals negative 6. X equals negative 2. So when I check that, if I put a negative 2 here, I have 3 to the negative 2 equals 1/9. If I have a negative 2 here, negative 2 plus 3 is 1. And we know 3 to the negative 2 is equal to 1/9. So my answer is good. All right, so in order to solve logarithms, you have to know that the inverse of an exponential is a logarithm, and the inverse of a logarithm is exponential. So to determine the inverse of this exponential function, we have to change it to a logarithm. So I have y equals a to the x. This is just review. X equals a to the y. So log base a of x equals y. So we are getting ready to change to logarithms to solve, or exponential vice versa. And remember, on a logarithm, that argument or the large number variable must be greater than 0. So when you have a logarithm that you're trying to solve, you have to think about your domains. All right, so a couple of basic ones. So 4 to the x equals 11. So this is exponential. So to solve an exponential, I change to a logarithm. So log base 4 of 11 equals x. Okay, so to get that properly written, you simply make your counterclockwise circle. So this piece is your calculator. So those of you with your TIs, go to that math key and find your log base. If you don't, I'm not going to write all these out like this, but you do log 11 over log 4. Change a base. So on this one, I got 1.73. You can check it, plugging it back in. You should get something close to 11 because we've rounded the answer. Okay, so this again is exponential. Inverse of an exponential is a log. So log base 7 of 15 is equal to 9x. You don't want to round as you go. You want to use your calculator as little as possible. So those of you with your TI-84s, just go ahead and divide by 9. And you get x is about 0.15. Those of you with the older calculators, go ahead and do log 15 divided by log 7. Press enter, and then just automatically go to divided by 9. So you're not rounding as you go. When you're doing your change of base, if you have to do that, you have to make sure you're using your parentheses properly. Okay, so this next one, if this were a nice number, I could figure it out without a calculator, which I still can. But this is a logarithm, so I have to change to exponential. So remember, this number has to be greater than 0 in order for this to work. So 3 to the 4th is equal to x. 3 to the 4th is equal to 81. So log base 3 of 81 is equal to 4. For this one, remember this is your common log, so you have log base 10. So the inverse of a log is exponential. So 10 squared equals x, x equals 100. So those were pretty basic. These will get a little bit more complicated as we go on for the rest of today and again tomorrow. Inverse of an exponential is a log. Inverse of a log is exponential. All right, so you need to make sure that these logarithms here are isolated, where you have a log, you have the base, and you have the argument, nothing else. So this one is simply going to go 4 to the 3rd is equal to 5x minus 1. One thing I forgot to talk about is this argument. Once you solve for x, has to be greater than 0. So 5x minus 1 has to be greater than 0. That means your x has to be greater than 1/5 in order for this logarithm to be defined. Okay, so 4 to the third is equal to 64. So all you're doing is solving a linear equation now. So 65 equals 5x, x equals 13. So that should work because 13 is greater than 1/5. We'll have to really worry about domain restrictions here in a minute. All right, so when solving a logarithm, the first thing you should do is figure out your domain. So that argument has to be greater than 0. So in this case, x has to be greater than 7/4. So to solve a log, you're going to change to exponential. So 5 to the third equals the argument, which is 4x minus 7. 5 to the third is equal to 125. And you're solving. So add 7, 132 equals 4x. Divide by 4, and you get x equals 33, which is in the domain, so you're good to go. All right, so on this one, that x squared could cause us some problems. So my argument is x squared minus 1. That has to be greater than 0. So x squared has to be greater than 1. But you got to think about this. X has to be greater than 1. This is a greater than problem, so or. Now I can't say x is greater than -1 because 0 is greater than -1, but 0 is not greater than 1. So less than or equal to, or just less than, sorry. Less than 1. -1. Okay, so the proper way to explain that, the way we do that in math analysis and calculus, is when I have, oops, I lost my stylus. Whenever I have an x squared, I go to my absolute value of x is greater than the square root of whatever is on the other side, which in this case is 1. So if you think about the absolute value of x, the absolute value of x greater than 1, anything greater than 1 is going to work. But then I have to change this to the negative value and switch my sign. So say x is equal to -2, the absolute value of -2 is greater than -1 because it's 2. So we should be good to go. All right, so these are my two restrictions. So I have 2 to the third is equal to x squared minus 1. 8 is equal to x squared minus 1. Add 1. 9 is equal to x squared. So x can be plus or minus 3. So I have x equals 3. X equals -3. So is 3 in the domain? Yes. 3 is greater than 1. Is -3 in the domain? Yes. -3 is less than -1. So both of those work. Okay, so last one, I need to isolate my natural log. So I'm going to add 2, just like I'm solving an equation, which I am. I need to get rid of the 3, so divide by 3. So now I have it isolated. I can change to exponential. E to the 6th is equal to x, which is the exact answer. Or you can go to your calculator, look above the natural log key, where there's an e to the x key, because they're inverses of each other. And you can press your e to the x key, put in a 6 for your power, and you should get 403.4. Okay, so remember this has to be greater than 0, which 403 is definitely greater than 0. So there is day 1, basically day 3 of logarithms, some basic solving. Tomorrow we'll get just a little bit more involved, but then good news, you have nothing left else new to do for Algebra 2.